Hello and welcome to Physics Projectile Motion in 2 Dimensions. So what we're going to do today is talk about when you shoot something into the air at an angle. It's called an angled launch. And so an angled launch has certain things that are given but not in the problem. So for instance, if you have a football that's being kicked at 27 meters per second at an angle of 30 degrees. So that's a projectile. It's being launched in the air. The only thing acting on it is going to be the acceleration due to gravity. So the football goes up in the air and it comes back down and it follows a parabolic path. And we pretend that there's no air. And since we pretend that there's no air, we can then say that in the x direction, the acceleration is 0. In the y direction, just like we've had before, the acceleration is due to gravity, and it's 9.8 meters per second squared. Other assumptions that are made is that when you take the original velocity and you break it down into its vectors, you're going to have an initial y velocity and an initial x velocity, and the x velocity stays the same throughout the flight. Because there's no acceleration in the x direction, and motion is independent of direction. So all the x's act the same and all the y's act the same. I just did that backwards. All the y's act the same and all the x's act the same. Because there's an acceleration in the y direction, this initial y velocity is going to get smaller and smaller and smaller until you get to the very top, and then the y velocity is 0. And because acceleration is still acting, it's the y velocity is then going to get larger and larger and larger until it hits the ground. Because of this, the amount of time up is equal to the amount of time down. Some of the things that you may be asked to find are where the football is going to land. So where the football lands is delta x, the change in x. How high the football goes is going to be delta y, and that's at the top of the trajectory. Other things that you can be asked for are the hang time, which would be the total time. So you have all of your motion equations that we had from one-dimensional motion. And we can use these all in an x direction or all in a y direction, but we can't mix x's and y's. And just like there were certain ones that we used for the half parabola problems, there will be certain ones that we're going to use for the full parabola problems. So this is all that's been given. The very first thing that you do, you can't use 27 meters per second at an angle. So you have to break it down into a y and an x component. So you have to be able to visualize the right triangle. The hypotenuse is going to be the 27 meters per second. And then you have this Vx, which makes up the 30-degree angle. And then if you look at this, this is really a rectangle. If you remember from geometry, the sides that are opposing on a rectangle, they're the same size. So that means that this side over here is Vy initial. And now you have a right triangle. So you can use sine and cosine. And you can say that the sine of 30 degrees is equal to the opposite side, which is Vy initial, divided by the hypotenuse, which is 27 meters per second. And then you can solve for Vy initial. If you remember your unit circle that some evil math teacher made you memorize, sine of 30 degrees, that's going to be a half. And so you take a half times 27, or you can just use your calculator. We get 13.5, and that's going to be meters per second. And then you do the same thing with cosine. The cosine of that angle is equal to the adjacent side. Here's the angle. The adjacent side is Vx, divided by the hypotenuse, that's across from your right triangle, that's your 27 meters per second. And now you can find Vx. 27 times cosine of 30. Make sure that you're in degrees, 23.4. Now that you have broken this down into X and Y components, you are allowed to use the algebraic equations. You can't use an algebraic equation for something that's at an angle. That's geometry. But once you break it down into Y's and X's, you're able to do that. So that means you never, ever, ever use that 27 meters per second again. You look at your equations and you see what you have. You know the initial velocity here. You know the y velocity up here is 0. You know that Vx stays the same. Because Vx stays the same, none of these equations are going to work in an x direction. The only one that's going to work in an x direction is the first one. So I take those variables and I make them all x's. So this is the velocity in the x direction is equal to the change in the x direction divided by the time. Well, I need to know the change in the horizontal displacement. That's one of the things the problem asked me. So I rearrange the equation and I get that. I know Vx, it's over here. The problem is I don't know the time. So I have to pick another equation and find the time. Well, if you look at the second equation, Ay equals Vyf minus Vyi divided by the time. I know Ay, it's negative 9.8 meters per second squared. I know Vy final if I say that this is the final velocity, it's up here at the top. If this is the final velocity, then that's 0. The initial y velocity is over here, and now I can rearrange this and find the time. So negative Vyi is negative 13.5 divided by negative 9.8 meters per second squared. 13.5 divided by 9.8 is 1.38. But that's only the time from here to here. So that's the amount of time to go up. Time to go down is exactly the same according to the rules for projectile motion. So that means that the hang time, or the total time, is 2.76 seconds. Add them together or double it, however you want to say that. So that's the total time. Now I can come back over here and figure out where the football lands. Delta x is from the beginning to the end. So I take Vx, 23.4 meters per second, and I multiply it by the total time, 2.76 seconds. It's 64.6 meters. That's where the football is going to land. The last thing I have to figure out is how high the football goes. I can choose from any of the last 4 equations. All of these are used in the y direction. You can't use the first one in the y direction. You have to use one of the other ones, and it doesn't matter which one. You need to pick one that has a distance in it. The easiest one is the third one. So I change everything to a y. So delta x, you can use the other ones. They're just harder to use. Delta x becomes delta y, half stays a half. V initial becomes Vy initial. V final becomes Vy final. Then you have to think about which time you're going to use. The maximum height is here in the middle of the parabola. That means you're going from here to there. That means you're going to use half of the time, or the 1.38 seconds. So how high the football goes? 1/2. The initial velocity is what we figured out over here, 13.5 meters per second. The final velocity is at the top of the trajectory, that's 0. You multiply that by half of the time, which is 1.38 seconds. Seconds will cancel out. Take a half times 13.5 times 1.38 seconds. The seconds will cancel out, and you'll be left with 1.32 meters. That's how you find maximum height, horizontal displacement,